Hey, this is Dr. Jones. So, I'm going to do one of the problems at the end of chapter 2. I'm going to do problem 2.8. And this is not a difficult problem at all, but let's take a look at it real quick. So, the first part that you need to do in reading this problem is just figure out what it's trying to do. Okay, so it says, if you'll go to page 54, problem 2.8, here you go. Claudia Progam Technologies, etc., has narrowed its choice of outsourcing provider to two firms located in different countries. Progam wants to decide which of the two countries is the better choice based on risk avoidance criteria. Which is the least risky choice? It's not on which is fastest, which is cheapest, which is best, or whatever. It's which is the least risky. And that's what the risk avoidance is. She has polled her executives and established 4 criteria. The resulting ratings for the two countries are presented in the table below, where 1 is a lower risk and 3 is a higher risk. I have recreated that table below, except I've added an extra 2 columns for the calculations that we're going to do, and I have put the weights in instead of leaving it in the text as you see. So, the executives determined the 4 criteria weightings, and you'll notice the price is 0.1, nearness 0.6, level of technology 0.2, and history is 0.1. Now, I think it's pretty interesting that 60% of the weight is on nearness of the facilities to the client. They see that the distance is a critical factor in this situation, that the farther away it is, the worse off. So the questions are, number 1, using factor rating method, which country would you select? And then number 2, or I guess B, A and B, if you double the weights to, in this situation, 0.2, 1.2, 0.4, and 0.2, would it change the outcomes? So let's see how you would do this within an Excel spreadsheet. This is an easy way to go. So you go to the first column, to, in this case, England, and you equals times the weight times England. And there you go on the first one. Then for Canada, you would do the same thing, weight times Canada. Now, I'm just going to center these. You don't have to do it, but I'm just going to do that. Now, this you will just copy. So notice how I'm just doing a pull down on each of these. Then you need to sum these up. So equals sum. There are other ways to do this. I'm just going to do it like this for the moment. And then copy that over and paste it there. Now remember, the whole point of this is which of these is the least risky. So whoever's got the lowest number is the least risky. So that means this right here, Canada, is the one that you would want to choose. That's the one that's the least risky alternative. So the second part of the question is, what if you doubled each of these? So let's just do that. Let's just put this in here. 0.2, 1.2, 0.4, 0.2. And what you'll notice is all you've done over here is you've doubled the size of each of them. You have not changed which one is the least risky. So doubling your weights is not going to make any difference because it's going to happen for each of them. Here's what is going to make a difference. Let's go back before we doubled those. So we're back to the original weights. If instead of nearness being a 0.6, let's say that you instead had this as a 0.3 and this as a 0.4. Now remember, this has to sum to 1. So notice now, by increasing the weight of price and decreasing nearness of the facilities, you've actually made these a toss-up choice, because Canada happens to be the riskier in terms of price, even though England is farther away from the client. So that's how you solve this problem right here. And that is what a factor rating problem does. Take a look for an upcoming problem where you will have to use a similar method out there using Excel spreadsheet. Take care.